Hello and welcome. I'm just going to be going over the meanings of quadratic sequence and linear sequence in this little short starter video. So quadratic sequences are just sequences that go up by a different amount each time. That amount could be larger or smaller, as you can see here in this top sequence. And this bottom sequence is a linear sequence, and it goes up by a set amount each time. In our questions that we're going to be doing, I'll be working with quadratic sequences and trying to find the nth term of them. So let's go on to the questions then. So in this first question we're asked to find the quadratic nth term of this sequence. So first I'm going to start off by trying to find the difference between each term. So 5 and 11, 6, 11 and 19 is 8, and 19 and 29 is 10, or plus 10, sorry, and 29 and 41 is plus 12. As you can see, there's a difference of, or a second difference of, plus 2 between each term. And this second difference is quite important for our first step. We're trying to get our n squared in our quadratic nth term sequence. So to get our, so the structure of our quadratic nth term would be something like this. I'll just write an example right up here. So n squared plus 15n plus 5. It could be negative, it could be decimals. These numbers don't have to be whole. But yeah, you'd have an n squared, you'd have an n, you'd have a whole number or just a decimal number. And it could be negative or positive. And that's what a n squared nth term looks like. So we're aiming for that, and to get our n squared we have to do this first. So we have to get our second difference, which is plus 2, then divide that by 2. So it's quite easy in this case because just 2 divided by 2 is 1, so our n squared would equal 1 n squared. So we can leave it as 1, or we can just leave it as n squared, or put the 1 in front of it because you just don't need to. And the second step would be to now use that n squared that we've got here, and I'll do this in a different colour. These are the numbers of each of the terms, and we're just going to sub in for each of these terms into this n. So for the first one, n would equal 1, for the second one, n would equal 2, and I'll do this right down here. So n squared, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and that's it. And then we'll put the corresponding term number, or the actual term, not the term number, sorry, the term in on top of it. So I'll do that in green. So the first term is 5, so we'll put that here. Second term is 11, put that on top of the 4, which is actually 2 squared, yeah. And then this one's 19, we'll put it on top of the 9. Then this one's 29, we'll put on top of the 26. Just put commas between these. And then finally there's the 41. And then we just subtract these two values. And then, yeah, we'll get a linear sequence from this. This will be 7, this will be 10, this will be 13, this will be 16, I think. Yes, 16. Cool. So we're just going to find the nth term of this linear sequence as normal, as we do normally. So we'll find the difference between each of these, which is plus 3. Oh, sorry, I should plus 3. I just can't fit that on here. Plus 3, and then we'll find the 0th term by going back a place. So with minus 3, and that gives us 1. So the nth term of this sequence would be 3n plus 1, and finally we just add that onto the n squared we have here. So our final answer would be n squared plus 3n plus 1. Yeah, and that's it. Now what this means is that if we get the term number, for example 1, and sub it into n, we'd get 5. If we sub in 2 for n, we'd get 11. If we sub in 3, we'll get, I don't know, 19, because that's the corresponding number. That's what we're doing here, and that's our answer. We can check if it's right by subbing some values into it. So if I want to find the fourth term, which we know is 29, I can sub in 4 into this, into the n. So 4 squared, where is it up here? For this one, 4 squared plus 3 times 4, so 4 times 3 or 3 times 4 is 12, and then plus 1. And what that should equal is 29, so if I've done this right. So 4 times 4 is 16, plus 12 plus 1. So 16 plus 12, so 26, 27, 28, 29. So that would equal 29, and that's our number here. So we know that this is right. And if it's not right, you might want to go back and specifically check whether you may have minus these the wrong way around. You might have done the n squared minus the term the actual terms themselves. So just go and check that if you've got it wrong. But yeah, let's move on to the next question. So in this second question, similar but harder question, we're going to start off the same and just find our second difference. So this is minus 4, minus 6, minus 8, and finally minus 10. The second difference here is minus 2. So we know that, shall draw them all in. So we know that we'll have to divide that by 2 to get the value for our n squared, and minus 2 divided by 2 is minus 1, so we'd get minus 1n squared or minus n squared as our value, and we'd just have to sub that in to each of the sequence numbers. So I'll do that down here in black. Minus n squared. We have minus 1, with minus 4, minus 9, minus 16, and minus 25. And remember, we're just subbing in the values from here. So 1 squared is 1, and times times the minus here, so it should be minus 1, minus 4, minus 9, minus 16, minus 25. And then we're just going to add the actual sequence values. So we've got 19, we've got 15, we've got 9, we've got 1, we've got minus 9, and I'm just going to subtract these. And this is harder than it looks because you got to remember that you've got a minus and a minus. So in this first one, 19 minus 1, so minus 1 would be 19 minus 1 would actually be 19 plus 1, because 2 minuses equal a plus, so that would actually be 20. It wouldn't be 18, so actually it would be 20, so you'd write 20 here. Same for this one, you'd have 19, this one you'd have 18, this one you'd have 17, this one you'd have 16. It's clearly going down by 1, and if you add 1 to get to your 0th term, as you do in linear sequences, you'd get 21. So your this nth term for this would be minus n plus 21, and our final nth term will just be minus n squared minus n plus 21. And we're done. Now this is the last question and it's for you, so pause the video here and have a go, and then unpause for the answer. So this is the answer, 0.5n squared minus 0.5n minus 3, which is the nth term for this quadratic sequence up here. So the way we got it was just using the usual steps that we've always used. So first we're going to try find the second difference as we've done here. So we got, that's in red, that's plus 1. Divide that by 2 to get a half, or 0.5. Put that in front of the n squared. That'll be our first part. So 0.5n squared. Then we sub that into our term numbers, and then we get these values right here, 0.5, 2, 4.5, 8, 12.5, and then we get our actual terms, minus them by the values that we've just got, and then we just have a linear sequence left over after we minus them, and then we find the nth term of that linear sequence, and it'll always be linear, but so it's just pretty simple, and then you just find the nth term of that, and then you add that onto the end of the n squared bit, and that's your answer. So thanks for watching this video, and hope you learned how to find the nth term of quadratic sequences. Bye.